The question in rotational dynamics is given multiple times. The question is like this. A thin circular ring of mass m and radius r is rotating in a horizontal plane about its axis vertical to its plane with a constant angular velocity omega. Let us try to stop there and understand what he is saying, right? A thin circular ring is rotating in a horizontal plane. This is a ring rotating in a horizontal plane like this. Its mass is capital M, its radius is capital R. I know the moment of inertia of a ring is mr square. It has an angular velocity omega. So it has an angular momentum L automatically, who is equal to I omega. L initial. I is mr square and omega. This is all given for you, right? If two objects each of mass small m attach gently to the opposite ends of diameter of the ring, what will be new angular velocities? Now what he is saying is, at the edges, two more masses are attached, each of small m, each from the axis at a distance radius. There is no external torque acting. So when no external torque is acting, angular momentum is conserved. That's the conservation of angular momentum. That is I1 omega 1 equal to I2 omega 2. I1 omega 1 is this much, L initial. What is I2 omega 2? I have to find out. To find out that I2 omega 2, first of all, I have to find out I2. Now the ring is rotating about the same axis, so the ring will have that moment of inertia, mr square, plus this point mass is rotating about the axis at a distance r, that each one will be having a moment of inertia small mr square and small mr square. That is together capital mr square plus 2m r square. Now, what is the new angular velocity is? As it was not mentioned that any external torque is acting, we shall assume that there is no torque acting. So momentum is conserved. I can use this formula. I1 omega 1 is mr square omega. I2 omega 2 means mr square plus 2 small mr square, because mass of the object kept was small m, whereas the mass of the circular ring is capital M. Omega 2 is how much I have to find out. It implies omega 2 equal to mr square omega by mr square plus 2m capital R square. R square is common both in numerator and denominator, that can be cancelled. So the new angular velocity is m omega by capital M plus 2m. That's the answer. Answer B is the answer option that is given for you to solve the problem. So do understand that to solve this problem, I have used basic concepts like when there is no torque acting, angular momentum is conserved. Angular momentum is I omega. So first I have calculated I of the circular ring. Omega is given for you. Next, when the masses are attached, moment of inertia got changed. I calculated the new moment of inertia and I used the conservation of angular momentum to get the new moment of inertia, new angular velocity. That's how we have to solve the problem. Thank you for watching.